Something just flew past our sun that shouldn't exist. A visitor from outside our solar system, and here's the part that stops scientists cold. It might be older than the sun itself, not older by a few million years, possibly billions of years older. NASA pointed the James Webb Space Telescope directly at it, and what came back is quietly rewriting everything we thought we knew about objects from other star systems. Stay locked in for the next few minutes, because this is easily one of the strangest confirmed space stories of the entire year. And if you want breakdowns like this before the rest of the internet even catches up, hit that follow button right now, because this channel is where you get the actual data, not the wild guesses being thrown around online. Let's break this down in the simplest way possible. Our solar system has one sun, 8 planets, a handful of moons, and countless smaller objects like asteroids and comets. All of them are chained to the sun's gravity. All of them travel in loops that repeat over and over again. Everything orbiting the sun belongs here, in the sense that gravity keeps yanking it back, locking it into a path around our star for what feels like forever. But every so often, something shows up that does not belong here at all. Something born far outside our solar system, somewhere deep in the wider galaxy, only passing through our neighborhood once before it vanishes forever, never to return again. These rare visitors have a name. They are called interstellar objects, and in all of recorded human history, we have only ever confirmed 3 of them. The first one appeared in 2017. It was small, oddly shaped, and tumbled through space in such a strange way that people kept debating it for years afterward. The second one arrived in 2019, behaving much more like a familiar comet with a glowing tail and clear cometary activity. Both of those objects came and went in a flash, and by the time telescopes were fully locked onto them, they were already fading into the dark. Slow down with me for a second, because understanding those first 2 visitors is exactly what makes the third one land like a punch to the gut. The very first confirmed interstellar object spotted back in 2017 was unlike anything astronomers had ever cataloged. It ripped through our solar system on a path that made it obvious it was not bound to the sun. And it carried a strange, elongated shape that made global headlines overnight. What made that first object so puzzling was how eerily quiet it stayed. It showed almost no visible activity, no clear gas or dust streaming off it the way a normal comet would, which made it maddeningly hard to study in detail. By the time telescopes truly understood what they were looking at, the object was already too far away and too faint to squeeze any more information from. It left more questions than answers behind it, and to this day, parts of its behavior are still argued about among scientists, purely because there was never enough time or data to fully explain what it really was before it disappeared. The second interstellar object arrived roughly 2 years later in 2019, and it behaved completely differently. It showed a glowing coma and a clear visible tail, acting much more like the comets astronomers were already familiar with from our own backyard. Because it was more active and easier to observe, scientists gathered a much richer set of data on its chemistry and structure than they ever managed with the first visitor. Even so, by the time telescopes were tracking it closely, it too was already on its way out, capping just how much could be learned before it slipped back into deep space forever. Both encounters left scientists starving for a third chance. One where a bigger, brighter, more active interstellar object might finally show up with enough warning time and enough brightness for the world's most powerful instruments, especially the newer tools that did not even exist back in 2017, to get a real, detailed look. And that is exactly what happened next. On July 1st, 2025, telescopes at a survey station in Rio Hurtado, Chile, spotted something moving fast across the sky. This station belongs to a network called the Asteroid Terrestrial Impact Last Alert System, a set of telescopes built specifically to scan the sky every single night for objects that could pose a danger to Earth. That night, the system flagged a faint, fast-moving point of light. Astronomers traced its path, and within days they had their answer. This object was moving far too fast to ever be trapped by the sun's gravity. It was not going to loop back around. It was going to punch through and keep going out into deep space, never to return. This was the third confirmed interstellar object ever recorded by humanity. It was eventually named 3I/Atlas, with the number 3 marking it as the third of its kind, an atlas honoring the telescope system that first caught sight of it. And right away, something about this new visitor stood out in a big way. Its path around the sun was more extreme, more sharply bent than either of the two interstellar objects before it. In simple terms, the shape of an object's path tells you how strongly it is or isn't attached to the sun's gravity. A path that curves gently and loops back is a sign of something that belongs here. A path that comes in fast, bends only slightly, and shoots straight back out is a sign of something only passing through. 3. I/Atlas had the most extreme, most sharply hyperbolic path of any interstellar object ever measured. It was screaming through our solar system at a staggering speed, well over 200,000 kilometers per hour when first discovered, and it only accelerated as it fell closer toward the sun. Here is where the story gets genuinely shocking, and it is the exact reason this opened with that line about the sun. Based on how fast this object is moving relative to the average motion of stars in our part of the galaxy, scientists were able to estimate roughly how long it has been drifting through space since it was first flung out of whatever star system originally birthed it. Their estimate placed its age somewhere between 3 billion and 11 billion years old. For comparison, our own sun and solar system are around 4.5 billion years old. That means it is entirely possible this comet is older than our sun. It may have formed around a star that lived and died long before our own sun ever ignited. And it has been silently drifting alone through the galaxy that entire time, completely untouched, until it happened to cross paths with our tiny corner of the universe. If that alone doesn't freeze you in place for a second, nothing will. A frozen piece of another solar system, possibly older than ours, just drifted close enough for our telescopes to actually study it up close. And this is where things got really interesting, because unlike the first interstellar visitor, which looked mostly inactive and rocky, 3 I/Atlas turned out to be a genuinely active comet. As it fell closer toward the sun, it began to heat up, and frozen material on its surface started turning directly into gas, streaming away and forming a glowing cloud around it called a coma, along with a faint tail. This activity was a massive breakthrough for scientists because an active object releases its internal chemistry into space, where telescopes can actually detect and analyze it. A quiet dead rock guards its secrets fiercely. An active, outgassing comet practically hands them over on a silver platter, and it is worth appreciating just how much coordinated effort it took to even find this object in the first place. The survey system that caught it is designed to scan enormous portions of the night sky over and over again, every single clear night, comparing each new image against the ones from the night before, hunting for anything that moved. Most of what it catches are ordinary asteroids, harmless rocks orbiting safely inside our own solar system. The system exists mainly to catch potentially dangerous asteroids early enough to calculate whether they pose any real risk to Earth. Catching a genuine interstellar object is an enormous bonus, a needle in an almost unimaginably large haystack of nightly sky images. The fact that this network caught 3 I/Atlas at all, and caught it early enough that astronomers worldwide had months of advance warning before its closest approach to the sun, gave scientists something they never truly had with the first two interstellar visitors: real lead time to plan and prepare detailed observations in advance. And that lead time changed everything because it meant space agencies could actually book time on some of the most in-demand telescopes on the planet, months ahead of the comet's closest approach, instead of scrambling at the last second the way teams had to with the earlier two visitors. Once the object's hyperbolic path was confirmed and its interstellar origin was locked in, observatories across the globe, along with space telescopes far above Earth's atmosphere, began lining up to take their turn studying it. Before going deeper, if you're genuinely locked into this, drop a follow right now, because what comes next is exactly what the James Webb Space Telescope found when it turned its instruments toward this ancient visitor. And it is stranger than most people expect. The James Webb Space Telescope, often just called JWST or Webb, is the most powerful space telescope humanity has ever built. It does not see light the way our eyes do. Instead, it is tuned to detect infrared light, a type of light with longer wavelengths than what we can see, which lets it pick up heat signatures and chemical fingerprints that are completely invisible to ordinary telescopes. That makes it perfect for studying the exact chemical makeup of distant, faint objects like comets. Webb was not originally designed with fast-moving small solar system objects in mind. Tracking something moving as fast as 3I/Atlas across the sky pushed the telescope's tracking systems in ways it was never really built for. Despite that challenge, engineers and astronomers managed to lock Webb onto the comet in August of 2025, capturing its first detailed spectrum, essentially a chemical fingerprint written in light. Then, after the comet swung around the sun and began heading back out of the solar system, Webb observed it again in mid-December of 2025, this time using a different instrument tuned specifically to mid-infrared wavelengths, capturing the most detailed chemical readout ever taken of any interstellar object in history. What came back stunned a lot of the scientists involved. The comet's chemistry was unusual compared to typical comets born inside our own solar system. For one, it showed an unusually high amount of carbon dioxide compared to water vapor, a ratio that clearly stood apart from the norm. Comets from our own solar system, which we have studied for decades, tend to follow certain expected patterns in how much water versus carbon dioxide they release as they heat up. This visitor from another star system shattered that pattern, hinting that whatever environment it originally formed in was chemically different from the one that built the comets native to our own neighborhood. Then came an even bigger discovery. Deep inside the mid-infrared data, scientists identified the unmistakable signature of methane gas streaming off the comet. This marked the first time methane has ever been directly detected coming from an interstellar object. Alongside the methane and carbon dioxide, Webb also picked up the clear signal of water vapor being released, plus something genuinely unexpected, a very specific atomic signature belonging to nickel. Finding a metal like nickel showing up in the gas escaping from a comet is unusual, and it tells scientists something about the raw ingredients that were mixed into this object back when it first formed, likely billions of years ago inside a completely different star system than our own. To understand why finding methane matters so much, you have to think about what methane actually is. It is an extremely simple, lightweight molecule, and it tends to be fragile. When exposed to raw cosmic radiation over long stretches of time, the exact kind of radiation an object drifting alone through interstellar space for billions of years would be constantly bombarded with, absolutely nothing shielding it. It should not survive easily. Because of that fragility, scientists never really expected to find much methane left on the outer surface of an object this ancient. Finding a strong, clear signal of it pouring off the comet was a genuine shock, and it forced researchers to think carefully about where exactly that methane was coming from. Scientists studying the sharp rise in methane compared to water believe the outer layers of the comet had lost much of their original methane over the billions of years it spent drifting through the brutal environment of deep space, exposed to cosmic radiation the entire time. What Webb was picking up, they believe, was methane escaping from deeper, unprocessed material buried beneath the surface. Material that had been shielded from that radiation for billions of years and was only now being exposed as the comet's outer layers boiled away in the heat of our sun. In simple terms, Webb was not just looking at the surface of this ancient visitor. It was looking straight into material that had been locked away, untouched since before our own solar system even existed. This is genuinely one of those moments where you have to stop and truly appreciate what just happened. A team of scientists pointed a telescope at a fast-moving speck of light, and that telescope managed to read out the actual chemical ingredients of a piece of another solar system. Ingredients frozen and hidden for possibly billions of years, untouched by anything until this exact moment. And Webb was not the only instrument studying this comet. NASA's Hubble Space Telescope also observed 3I/Atlas, both shortly after its discovery and again after it whipped past the sun. Hubble's early observations gave scientists their first rough estimate of how big the solid core, or nucleus, of the comet actually is buried underneath all that glowing gas and dust. Later observations, once the comet's activity had settled down a bit after its closest approach to the sun, let scientists get a cleaner measurement separating the faint glow of the solid core from the much brighter surrounding coma. Estimates for the nucleus size shifted a bit as more data came in, but the most refined measurements place its solid core at roughly 2.5 kilometers across, making it noticeably larger than either of the two interstellar objects discovered before it. That larger size is actually part of the reason 3I/Atlas became so much brighter and easier to study in detail than its predecessors ever were. A bigger nucleus means more surface area available to heat up and release gas as the comet approaches the Sun, which in turn means a brighter, richer coma for telescopes to study and ultimately a stronger, clearer chemical signal for instruments like Webb to lock onto. Size alone doesn't guarantee good data, but in this case it gave scientists a real advantage over what they had with the fainter, smaller objects seen in 2017 and 2019. Measuring the exact size of a comet's solid nucleus is trickier than it sounds, because from a telescope's point of view, the tiny solid core is almost always drowned out by the far brighter cloud of gas and dust surrounding it. Astronomers have to use careful modeling, combining brightness measurements at different wavelengths with knowledge of how reflective different surface materials tend to be, to separate the faint signal of the actual rocky and icy core from the glow of everything surrounding it. That is part of why nucleus size estimates for 3 I/Atlas shifted somewhat as more observations came in over time, starting with a fairly wide early range and narrowing down to a more confident estimate once the comet's activity had settled following its closest approach to the Sun. On top of Webb and Hubble, other instruments joined the effort too. A space telescope called SPHEREX, designed to survey the entire sky in infrared light, took its own look at the comet in December of 2025 and picked up signs of increasing activity after its closest pass by the Sun, along with detecting dust made of tougher, more heat-resistant material mixed into the coma, plus additional gas signatures that added even more detail to the comet's chemical story. Ground-based radio telescopes using a technique called ALMA observations also chipped in, detecting other molecules escaping from the comet, including methanol and hydrogen cyanide, adding yet more pieces to the puzzle of exactly what this ancient visitor is truly made of. If you're still locked in at this point, you clearly value real science over hype. So go ahead and hit that follow button right now, because there is one more part of this story that a lot of people online have been getting completely wrong, and it deserves to be set straight. Because 3 I/Atlas was moving on such an extreme path, and because it turned out to be surprisingly large and surprisingly old, some corners of the internet ran wild with speculation, throwing around theories that it might not be a natural object at all. When something unusual arrives from outside our solar system, it is a completely natural human reaction to wonder what else it could be. Scientists take that curiosity seriously, and rather than dismissing it outright, they actually went and checked. Researchers used radio telescope arrays specifically designed to search for what are called technosignatures, meaning any kind of artificial radio signal that might suggest an object was built rather than formed naturally. They pointed these instruments directly at 3 I/Atlas during its journey through our solar system and listened carefully across a wide range of radio frequencies. And the result of that search was crystal clear. No artificial signals were detected. Every single piece of data collected across every instrument, from Webb's chemical fingerprint to Hubble's imaging to the radio searches, points to exactly what an ancient natural comet should look like. Its behavior matches known cometary physics. Its chemistry, while unusual, fits within the range of what scientists expect from an icy body that formed around a different star. Its overall structure, its coma, its gas emissions, its dust, all of it lines up perfectly with a natural interstellar comet, not anything constructed or artificial. This isn't being brought up to dismiss curiosity, because honestly, the real verified science here is already wild enough on its own without needing to add anything to it. A confirmed visitor from another solar system, possibly billions of years old, carrying chemical fingerprints frozen since before our own sun existed, studied directly by our most advanced space telescopes. That is already one of the most remarkable natural discoveries of the decade. It does not need embellishment. The truth here is stranger and more grounded than the rumors ever could be. So what does all of this actually mean going forward? Why should any of this matter to someone who isn't an astronomer? For one, every interstellar object we get the chance to study up close hand scientists a genuine physical sample of material born somewhere else entirely around a star system we will likely never visit or even directly see in detail. Instead of only theorizing about what other star systems might be made of based on distant light readings from telescopes pointed at faraway stars, an interstellar object lets scientists directly measure the raw ingredients that built planets and comets somewhere else in the galaxy. That is an extraordinarily rare opportunity, We have only had 3 chances like this in all of recorded history, and 3I/Atlas gave scientists by far the most detailed data set of the 3, largely because of its size, its activity level, and the sheer amount of advanced instrumentation available to study it compared to what existed when the first interstellar object showed up back in 2017. There is also a much bigger scientific picture forming here. Each interstellar object we detect adds to our understanding of just how common these wandering objects actually are throughout the galaxy. For a long time, scientists debated whether interstellar visitors like this were incredibly rare, one-off events, or whether space is actually full of them, quietly drifting past us undetected simply because we did not have the tools or the timing to catch them. The fact that we have now confirmed 3 of these objects within less than a decade, with detection technology still improving every single year, suggests these visitors might be far more common than anyone originally guessed. As newer, more powerful sky survey telescopes come online in the coming years, scientists expect the detection rate of interstellar objects to climb dramatically. In other words, 3I/Atlas may not be some rare once-in-a-lifetime event. It might just be the 3rd confirmed sighting in what could become a fairly regular stream of ancient visitors passing quietly through our neighborhood, most of which we simply have not had the tools to catch until now. That thought alone should change how you look up at the night sky. Somewhere out there, right now, more pieces of other solar systems are almost certainly drifting through our own. Ancient, frozen, and completely unnoticed, waiting for the next telescope powerful enough and lucky enough to catch sight of them before they slip back out into the dark forever. There is also a very practical reason astronomers are so eager to build better detection systems going forward. A brand new ground-based survey telescope, purpose-built to scan the entire visible sky every few nights with extraordinary sensitivity, recently began full operations, and many scientists expect it to dramatically speed up how quickly future interstellar objects get identified after entering our solar system. More warning time means more opportunities to line up telescopes like Webb and Hubble well in advance, the same way astronomers were able to with 3I/Atlas instead of racing against the clock the way teams had to with the very first interstellar visitor back in 2017. Every improvement in detection technology directly translates into richer, more detailed science the next time one of these ancient wanderers passes through. It is also worth remembering just how much combined effort across different countries and institutions went into fully understanding this one comet. The initial detection came from a ground-based survey network. Confirmation and orbit calculations involved observatories and researchers across multiple continents comparing notes within days of the discovery. Space telescopes operated by different national space agencies then took turns studying it from orbit, each one contributing a different piece of the chemical puzzle. Radio telescope arrays added still more detail from an entirely different part of the light spectrum. This is genuinely one of the more impressive examples of global scientific cooperation happening quietly in the background, with teams around the world sharing data and coordinating schedules, all working together toward one shared goal: understanding this single ancient visitor as completely as possible before it disappeared from view for good. Sit with the timeline of everything this comet has been through for a moment, because it really puts the scale of this discovery into perspective. This object formed billions of years ago somewhere around a star that may not even exist anymore, in a completely different region of the galaxy. At some point in its ancient history, gravitational interactions with other objects, or perhaps a close encounter with a passing star, flung it out of that system entirely, sending it drifting alone through the emptiness of interstellar space with no star to orbit, no light to warm it, just endless cold and silence. For possibly billions of years, it drifted like that, tumbling through the space between stars, completely untouched, carrying its original chemistry locked away and frozen. Then, purely by chance, its long, silent journey brought it close enough to our sun that our own solar system's gravity could finally bend its path, and our telescopes could finally catch sight of it. It swept past the sun, warmed up just enough to release some of that ancient frozen material into space, giving our instruments a brief window to study it, and then it continued on its way, heading back out into the depths of the galaxy, likely never to return, possibly never to be seen by anyone ever again. Think about that against the full timeline of human history. Telescopes themselves have only existed for around 400 years. Space telescopes capable of reading the precise chemical fingerprints of a comet have only existed for a few decades. Out of the billions of years this object spent drifting silently through the galaxy, it happened to pass close to our sun during the exact narrow window of human history when we had both the knowledge to recognize it as interstellar and the technology to study it in real time. A few hundred years earlier, and it would have simply been an unexplained blurry point of light in the sky. We happened to be alive, with the right telescopes pointed at the right patch of sky, during the one brief moment this ancient traveler passed close enough to notice. That is an extraordinary stroke of cosmic timing, and it is worth appreciating just how much effort, coordination, and advanced engineering it took across multiple space telescopes and observatories around the world to make the most of that narrow window before the comet faded from view for good. Scientists are still analyzing every scrap of data collected from 3I/Atlas, and more detailed findings are expected to keep rolling out over the following months as researchers dig deeper into everything Webb, Hubble, and the other instruments managed to capture. Findings from this comet were formally published in a leading scientific journal, confirming its ancient cold origins and cementing its place as the most thoroughly studied interstellar object humanity has ever encountered. Every new detail adds another small piece to a much bigger puzzle about how solar systems form, how common these interstellar wanderers really are, and what other star systems out there in the galaxy might actually be made of. If this story genuinely gave you a new appreciation for what real, verified space science can uncover, make sure you're following this channel because every confirmed development on this story and every other major discovery like it will be tracked right here as the data continues rolling in. Share this with someone who needs to hear about it instead of the wild theories floating around online, because the actual truth here is honestly more incredible than the rumors ever were. To wrap this up simply, in the summer of 2025, a fast-moving object was spotted heading through our solar system, and within days, scientists confirmed it was not from around here at all. It was the third confirmed interstellar object in recorded history, and it turned out to be one of the most extreme ones ever measured, moving on the sharpest, most hyperbolic path scientists had ever tracked. Estimates suggest this ancient comet could be somewhere between 3 and 11 billion years old, meaning it is entirely possible it formed before our own sun even existed. As it swept past the sun in October of 2025, it heated up and became active, releasing gas and dust that our most advanced telescopes were finally able to study directly. The James Webb Space Telescope captured detailed chemical readings showing unusually high carbon dioxide, the first ever direct detection of methane from an interstellar object, clear water vapor signatures, and even a rare atomic signal from nickel, all pointing to chemistry that likely formed in a completely different star system than our own. Hubble helped pin down its size. Other instruments like SPHEREX and ground-based radio telescopes added even more chemical detail, and dedicated searches for artificial signals came back completely clear, confirming this is exactly what it appears to be. A genuine, natural, ancient piece of another solar system passing quietly through our own before heading back out into deep space, likely never to return. That is the real story, backed by real data from real telescopes, gathered by real scientists working together across the globe to make sense of one extraordinary visitor. And it is stories like this one, grounded entirely in verified science, that this channel exists to bring you first. Follow now if you haven't already. Drop a comment telling me what part of this surprised you the most, and share this with someone who would find this as fascinating as you clearly do. We will see you in the next one.